This section covers basic formulas for determining the number of various possible types of outcomes. The topics covered are 1. Counting the number of possible orders, 2. Counting using the multiplication rule, 3. Counting the number of permutations, and 4. Counting the number of combinations. Suppose you have a plate with 3 pieces of candy in it, 1 green, 1 yellow, and 1 red. You are going to pick up these 3 pieces one at a time. The question is, in how many different orders can you pick up the pieces? All the possible orders are shown here. There are 2 orders in which red is first, red, yellow, green, and red, green, yellow. Similarly, there are 2 orders in which yellow is first, and 2 orders in which green is first. This makes 6 possible orders in which the pieces can be picked up. The formula for the number of orders is shown on the right. The number of orders equals n factorial, where n is the number of pieces to be picked up. The exclamation point stands for factorial. If there were 5 pieces of candy to be picked up, they could be picked up in any of 5 factorial, or 120, orders. Imagine a small restaurant whose menu has 3 soups, 6 entrees, and 4 desserts. How many possible meals are there? The answer is calculated by multiplying the numbers, 3 times 6 times 4, which equals 72. You can think of it as, first, there is a choice among 3 soups. Then, for each of these choices, there is a choice among 6 entrees, resulting in 3 times 6, which equals 18, possibilities. Then, for each of these 18 possibilities, there are 4 possible desserts, leaving 18 times 4, which equals 72 total possibilities. Suppose that there were 4 pieces of candy, red, yellow, green, and brown, and you were only going to pick up exactly 2 pieces. How many ways are there of picking up 2 pieces? All the possibilities are listed here. The first choice can be any of the 4 colors. For each of these 4 first choices, there are 3 second choices. Therefore, there are 4 times 3, which equals 12, possibilities. More formally, this question is asking the number of permutations of 4 things taken 2 at a time. The general formula is shown on the top. NPR is the number of permutations of n things taken r at a time. In other words, it is the number of ways r things can be selected from a group of n things. The formula for 4 things taken 2 at a time is shown on the bottom. It is important to note that order counts in permutations. That is, choosing red and then yellow is counted separately from choosing yellow and then red. Therefore, permutations refer to the number of ways of choosing rather than the number of possible outcomes. When order of choice is not considered, the formula for combinations is used. Now suppose that you are not concerned with the way the pieces of candy are chosen, but only in the final choices. In other words, how many different combinations of 2 pieces you could end up with. In counting combinations, choosing red and then yellow is the same as choosing yellow and then red, because in both cases you end up with 1 red piece and 1 yellow piece. Unlike permutations, order does not count. This table is based on the table showing permutations, but is modified so that repeated combinations are given an x instead of a number. For example, yellow then red has an x, because the combination of red and yellow was already included as choice number 1. As you can see, there are 6 possible combinations. More formally, this question is asking the number of combinations of 4 things taken 2 at a time. The general formula is shown on the top. NCR is the number of combinations of n things taken r at a time. In other words, it is the number of ways r things can be selected from a group of n things. The formula for 4 things taken 2 at a time is shown on the bottom. It is important to note that order counts in combinations. That is, choosing red and then yellow is counted the same as choosing yellow and then red. Therefore, combinations refer to the number of possible outcomes.